So this next section is actually going to talk about a solid we haven't actually mentioned yet, a sphere. So we've talked about all the other kind of cylinders, prisms, cones, pyramids. The one thing we've left off is a sphere. And notice we're going to talk about both surface area and volume in just one day, mainly because these formulas are very kind of
They're
basic.
different from the others, but they're
different and they're a little more basic. Okay, and the reason why they're different is because there's not really any similarities with any of the other things. There's no bases, there's no vertex, things like that. Right? So what exactly is a sphere? Now, by the mathematical definition, if you look it up in the book, it says it's a locus of points in space that are given distance from a point, which is the center of the sphere. Okay,
so if I had a point in the middle and I just maybe took a little piece of string and I held that string out away from that point, the same distance all the way around, all those points together would make that sphere. It's a ball. Can we just say it's a ball?
Depending on, not a football.
No, not a football. It would
be so anything that kind of has a lot of people. I think some people want to define sphere, say it's like a three-dimensional circle. However, circles are not three-dimensional, but it has some similar features of a circle.
Right.
So it is three-dimensional. It's going to have that kind of round shape. It's going to look kind of like a basketball or a volleyball or whatever. Okay. Now, because it has some similar features of a circle, notice the next definition. We have a radius of a sphere. And it's basically the segment from the center to a point that's on the sphere. Just like a radius of a circle, it goes from the center to a point on the circle, right? So here we have a picture, kind of a visual of a sphere. Now, I know it kind of looks like a circle. That's how we start it. You start kind of drawing it, but then you have this like little ring to show that it has a three-dimensional dimension. So from the center to a point on the sphere is considered a radius, okay? Now, a chord of a sphere. Now, chords we haven't been spent a lot of time with. We're going to see that more so in Chapter 10.
Right.
A chord is just any segment whose endpoints are on the sphere. So it has to have endpoints that are on the sphere. So would a radius be considered a chord?
Well, no, because only one endpoint is on the sphere. The other one is at the center.
Okay. So chords and radius aren't the same thing.
Now, a diameter.
If we look on ahead, a diameter is a type of chord that contains a center. So basically, it's, in a sense, the longest chord. Okay, I'm going to make a little note to there and something you might do. It ends up always being the longest chord because it has to go through the center of the circle, or sphere. I keep saying that, sorry. So a diameter is a type of chord because the endpoints are on the sphere and it has to go through the center. Just like a diameter in a circle has to go through the center as well. Okay,
Right.
So some vocabulary.
All right. Another vocabulary term is what we call the great circle. The great circle is the intersection of a sphere and a plane. So it's just like a cross section. We can kind of think about it. We've talked about that word before. That contains the center of the sphere. So if we think about doing a cross section that goes through the center, notice that that circle is going to have some special characteristics of the sphere in it. Because what do we know if it contains the center of the circle? What do we call the distance that goes from the center of the circle to any point on that sphere?
That's the radius. So the great circle will contain the radius.
It will contain the radius.
Instead of just saying contain the center, it's going to contain the radius too. And I'm thinking of other things that go through the center, diameter too. So it's going to contain the radius and the diameter.
Perfect. So the radius and the diameter of the great circle are the same as the radius and the diameter of the sphere.
Okay, that makes sense.
It is the largest circle that you can make if you do a cross section.
Because if you slice it anywhere else, you're going to get a cross section that's a circle, but because it's not going to contain the radius or diameter, it's not going to be the largest circle.
Right.
It's kind of like if you take an orange, guys, and you slice it right down kind of the center of that orange, which would be going through the center of the sphere. That, if you open it up, that is going to be your great circle.
Right. Every great circle divides the sphere into two congruent halves, and we call those hemispheres. And a lot of times that's a word you hear in social studies classes when you're talking about parts of the world. All right, we talk about a northern hemisphere and a southern hemisphere, etc. So these are all parts of the greats, or what the great circle helps do too.
Okay, so we're obviously going to be talking about surface area and volume. There are two formulas that we're going to be learning. Notice the surface area formula. It says surface area of a sphere. And notice it doesn't have to be any special type of sphere. Like we don't have to have a right sphere or a regular sphere. A sphere is a sphere. Notice the formula. It says 4 pi r squared. So really all you need to know about the sphere is the
area of the base area times 4.
Okay, but there's not really
just
a
the-
base.
I see
The
what you're
radius.
saying, yeah.
We just because there's not really a base.
There's not a base.
in
you're
a,
right.
in a sphere. So we're not doing
I'm
a
thinking
base
more of a
area.
great circle.
Yeah.
But yeah, you're right.
We're finding all we need to know is the distance from the center to a point on the sphere. If
That's
I know
great.
that, then I can find the formula.
Yeah.
Okay. So pi r squared is essentially the area of the great circle, and there's basically 4 times that cover the surface, because great circle is actually inside the sphere. Okay.
Right.
So when you're
That's
talking
true.
about surface, you're talking about what surrounds it. Okay. Kind of like this, kind of and like a baseball. The leather that covers the baseball is the actual surface area. All right. Or a basketball, the leather that covers the basketball. What's inside of it, like in a basketball, would be the air. That would be
Right.
the volume. Okay.
Okay.
So volume formula. Let me just go ahead and talk about that one. The volume of sphere. Volume is the stuff inside, of course. So notice the formula is a little bit different. All right. One thing that I notice is there's a fraction involved, 4/3. You still see pi, but instead of r squared, it's r cubed. Okay.
Which with volume we see cubic units and surface area we see squared units. So that's kind of a way to remember.
Makes sense, okay? But I do see that people mix it up.
Yeah.
All right. Now, another way of writing this, and I personally like to write it this way just because 4/3, we're not a big fan of maybe multiplying by it. So another way of writing it would be saying 4 pi r cubed and then divided by 3.
Yeah.
Okay, which essentially means the same thing. So I'm going to encourage you guys to use it this way. The book writes it this way, but it means the same thing. Okay, so again, volume versus surface area, notice the differences there. So let's just apply some of the stuff we've learned.
Okay, so we've got some examples. The first one says find the surface area of the sphere. And again, anytime you come across any problem and you see the directions of you're finding a surface area volume of a certain type of figure, what's the first thing we should do?
Let's write the formula.
All right, so surface area of a sphere is what was that formula?
4 pi r squared.
Awesome. Now, do we have the radius?
That's all we need, and that's what we have. Yeah.
All right, so let's go ahead and let's put that in. So surface area is going to equal 4 pi times our 12 squared.
So that basically means 144 times 4, and that is 576 pi. Now, I see units, so do I need a round?
Probably need a round.
Yes, but that would be exact.
This would be exact.
And let's multiply that by pi, so it's 1,809.56 centimeters squared, because we're talking about surface area.
Love it. Pretty easy to use these formulas because, again, you only have one unknown.
Yes. All right. The next question says, the circumference of a great circle is 15.5 pi meters. All right. Find the surface area of the sphere. Now, I want you to think about this. It says we're finding the surface area of the sphere.
So we know we need that formula. So
What's that formula?
The surface area is equal to 4 pi r squared.
So the only way we can find the surface area is if I know
The radius.
the radius. Okay, now, what's the radius again?
The radius goes from the center of the sphere to any point on the sphere.
Okay. Think about what they're giving you. They're probably giving that for a reason. They tell you that the circumference of the great circle is 15.5 pi. Don't forget the pi.
Okay.
Meters. Now,
Okay, but the great circle had that same radius in common.
and if you think about it, let me go back real quick. Let me find that slide, the radius. So the great circle kind of is that cross section where it contains the center. So they're giving you basically the distance around the largest part of the sphere in a sense. Okay.
Right.
So if I know find the problem, sorry guys. If I know the circumference of the great circle, will that help us find the radius, which then will find the sphere,
Sure.
surface area?
Because circumference we know is going to be 2 pi r.
And if they give you the circumference is
the 15.5 pi.
We can find the radius, right? Because
Right.
they contain the same radius.
Absolutely.
So how do I get the r? I'm just going to...
Divide by 2 pi.
Now, when I divide by 2 pi, notice the pi's will cancel out. So you're essentially just doing 15.5 divided by 2.
Right,
So the
which
radius is...
7.75.
Am I done?
No, that's just the radius. So now I'm going to put that into the formula for the r. So I want to take 7.75 and I'm going to square it. And then I'm going to go ahead and, because I notice we've got meters, I'm going to get the decimal answer. So I'm going to take that 7.75 squared times 4 pi. And that is going to give us 754.77 meters squared.
So this one you had to kind of work for it. So, but it's still, again, if they say find the surface area, you need to know the radius.
Right.
Okay, so keep that in mind.
Okay, now this next one says, what is the radius of a sphere modeled from the cylinder of modeling clay? So this is like, okay, imagine you got a tube of Play-Doh or a container of Play-Doh. And you know when you first get it out, it looks like the cylinder that it was in, right?
Yeah, yeah.
So here's the thing. Right now we have a cylinder of Play-Doh.
Uh-huh.
We want to make a sphere of Play-Doh. That's a common thing you used to do when you were
Yeah,
little.
you roll it into a ball.
Roll
yeah.
it into a ball. Okay, what's the same about the Play-Doh that we're using?
Okay, so if I'm kind of getting a visual in my hand. If you want to even get Play-Doh out and do this. So you have this cylinder of Play-Doh, and I roll it up. I'm changing, obviously, the look of it, okay? But I'm not taking the Play-Doh away, right?
Right.
So really, the stuff inside of that cylinder is going to be the same as stuff inside of the sphere. So I'm thinking volume doesn't change.
Right. And that's exactly
So
right.
the volume is going to be the same for both.
So let's keep track of that. The volume is the same, that's for sure.
Okay.
So really, I need to know kind of the volume of this.
Yes,
That's
because
gonna
the
be
only way I
important.
can find the radius of a sphere is if I know that maybe the surface area or volume or if I know the great circle, something about it. But yeah, I'm thinking volume. Let's find the volume of that cylinder.
Okay. And it sounds like we're going to need to find the volume of a sphere.
Mm-hmm.
So just out of curiosity, what is the volume of a sphere? What is that formula?
That's the 4 pi r cubed divided by 3. Now, we're not actually finding the volume of this
finding that
because we
yet.
don't know the radius.
Right.
So the only
That
way...
may help us to find the radius because we're going to know a volume. Now, what we have here, though, is a what?
That's a cylinder.
So let's talk about the volume of a cylinder.
And again, the reason why we're doing this is because the volume didn't change. The stuff that made that clay didn't change. So to find the volume of a cylinder, that's your pi r squared, or base area, times the height.
Right, and I'll even put that on here, pi r squared. Okay, now, one thing I want to point out, the radius of a cylinder does not mean that that's the same radius of the sphere.
I like that you pointed that. Because if I change the shape of it, that I'm thinking probably the radius of the sphere is going to be actually bigger than that cylinder.
It would make sense, yeah.
Because you're kind of condensing it more in a
Yeah.
sense.
Okay, so let's fill in what we know to find the volume of this sphere. all
Okay,
right?
so I'm going to do volume equals, I'm going to do pi times the r squared, so the 2 squared, times the height of 16.
Okay,
So that's going to get you 64 pi. And here's what I think I want to do. I want to leave it as 64 pi.
I think that's probably a great
Guys,
idea.
really no reason to round. I know some of you have been doing that. Let's not do that yet. Don't do it till you absolutely. That's 64 pi is kind of nice, okay?
So this is the volume. That's the amount of clay that we have. It's the same amount that we have over here. So if I put a 64 pi in for that volume,
Yes,
that would allow me to then find my one unknown,
which is my radius.
which is my radius.
So I'm looking at that, and you're essentially just solving for r. So it's just an algebraic equation, essentially. All right, so here's what I'm thinking. I'm thinking because 3 doesn't divide into 4, so I'm just going to get rid of that by multiplying each side by 3.
Okay.
And then when I multiply 64 pi times 3, and I'm just going to do 64 times 3, I get 192 pi.
And that's equal to our 4 pi r cubed.
Okay, so I'm still trying to get r by itself. So I'm going to go ahead and divide by 4 pi. Now, yes, we usually say put it in parentheses, but I'm noticing the pi's are going to cancel out. So I'm
Right.
really only doing 92 divided by 4. And so you get r cubed equals 48. Now, remember back when we talked about when we're cubing something, to undo the cubing, what are we going to do?
We're going to do a third root.
Cube root.
Mm-hmm. Same thing.
Yeah. Same thing, yes. So how we do that? We're going to, again, we need to put that 3 in first, and then the second, and there's that caret key, so it has 3 that acts radical. All right?
Go ahead.
And then put in 48.
And what do you end up with?
This ends up being an approximate about 3.63, and this is centimeters because we're talking about linear units.
Right. And we're not talking about the volume here, so we're not talking about cubic units. This is they're just centimeters because it's a linear measure. Awesome.
All right, it says a baseball has a diameter of 2.9 inches. Okay, so a baseball obviously is a
sphere.
All right, and they give you the diameter of it. It says find the amount of leather covering the baseball. So we need to figure out how much covers the baseball. So
that's
what are we
surface area.
Yeah. So we're finding surface area, which is the formula is
4 pi r squared.
So do they give you the radius?
They do not give us the radius, but they do give us the diameter, which will allow us to find the radius.
And what do we do with that diameter to find the radius?
We are going to take half of it.
Take half of it. So if to find the radius, we're going to just do 2.9 divided by 2. So what's the radius?
The radius will be 1.45.
So I'm just going to put that into my formula. And I'm noticing there's already units, so it's okay if you just type it all in and get a rounded answer.
Right.
So how much leather approximately covers the baseball?
Let's see how that should. Oh, that would help if I used a decimal. Okay, 4 pi times 1.45 squared is going to give us our 26.42.
And this is in square inches.
Yes.
That covers the baseball, okay? Right. This one is a little, not necessarily tricky. You just have to, like the last one, they didn't specifically say find the volume, find the surface area. You had to kind of think about it.
All right, next one. You melt a 4-inch diameter sphere of wax and you pour it into a cylindrical 2-inch diameter candle mold. How tall can you make the candle?
Okay.
Okay, now let's talk again for a minute because here I see that we've got a cylinder and we've got a sphere.
Okay.
Okay. If this is taking a ball of wax,
okay,
and melting it to where I can make a candle mold out of it.
Okay.
Okay. What's the same with both of those?
Well, I'm thinking like the last one, but I'm also thinking, well, if I'm melting it and pouring it in there, the shape changes, but it's like the stuff that makes it. The wax isn't changing. So
Right.
like the volume is staying. The stuff inside doesn't change. So this is kind of like that one a couple slides ago. So the volume doesn't change. So essentially that means the volume of a sphere is going to equal the volume of the cylinder.
Right.
Okay.
So let's go ahead and let's talk about those two formulas. For first of all, volume of a sphere, we're going to have what?
4 pi r cubed divided by 3.
And for volume of a cylinder,
it is, I'm going to do just pi r squared times the height.
okay, because we know that is the area of the base. All right, now let's talk about what do we already know.
Well, they give you that the diameter of the sphere is 4 inches. Okay, so that's going to tell us that the radius actually is 2.
All right, so let's go ahead and it sounds like we can right now
find the volume of the sphere.
Find the volume of the sphere. So let's do that. We've got the volume will equal our 4 pi times 2 cubed all over 3.
All right, so I'm going to do 2 cubed. That's going to be your 8 times 4. That's 32 pi over 3. Now, here's the deal, guys. Let's just leave it like that. Okay, trust me. There's no reason to do 32 divided by 3 and get, it's not going to be a convenient decimal.
Ugly. Yeah.
Okay.
So this is the volume of wax.
Of the wax, which is the sphere and the cylinder.
So this 32 pi over 3 is also the volume for the cylinder. And that's equal to our pi r squared times the height. Now, let's go back and look at what else we know. We want our cylinder to have a 2-inch diameter.
Which means the radius of that diameter has to be 1.
So right now I could go ahead and put a 1 in place of my r, which by the way, 1 squared is just
1.
Is that changing the value of anything over
No.
there? So we've really got 32 pi over 3 is equal to pi h. Or if you wanted to write 1 pi h, same thing. The question is, how tall can you make this candle? Which is the only unknown that I have right now, my height. Okay, so what are you thinking, Mrs. Palermo?
Well, I know I got to find the h, and the only way I can do that is basically divide by pi. So if I divide both sides by pi, all right,
and this looks kind of ugly, but if
just put it underneath.
right,
yeah.
exactly.
And essentially, the pi's are going to cancel over there. So the height is going to be that 32 over 3. Now, I have units, so I'm just going to do 32 divided by 3, and I get approximately 10.67 inches.